Okay, so to gain some familiarity with this new rule for the EMF when the wires are moving and the magnetic field is constant, let's see how we can get the EMF using this rule for this particular simple problem. So first, what is the direction of V wire cross B? The velocity of the wire, this rod is moving to the right. Everything else is fixed in space. So when the velocity of the wire is to the right, so V cross B, the magnetic field is into the page. V cross B is actually which direction? It's upwards. So if you want to get the EMF going around the loop this way, remember EMF you have to, around a closed loop, you have to specify, do you want to go around this way or this way? So we choose to go around this way. Then the ds vectors, what's the angle between the ds vector and the V cross B vector for this part of the rod? Clearly the angle is 0. So we can write that V cross B dot ds is the magnitude of V cross B times the magnitude of ds times cosine of the angle between them. Cosine 0 is 1. So we can write the EMF in this form. Okay, what's the magnitude of the cross product between two vectors? Magnitude of the first, magnitude of the second, times sine of the angle between them. What's the angle between V wire and B? V wire is to the right, magnetic field is into the page, the angle is 90 degrees, sine 90 is 1. So the EMF turns out to be, you can write it this form. Now the velocity of the wire, the speed of the wire is just constant. The magnetic field is constant. I can take them out of the integration. So what's integration from B to A of ds? I want to add this distance plus all these distances. What do you get? You just get the length of the rod. So you get L. So integration of ds is just, so we see that the EMF in this circuit is the speed of the wire, magnetic field times the length. This is just exactly what we got for the potential difference across the rod in a magnetic field, right? Did we get the potential difference was BLV? So it makes sense now that this battery is the source of EMF, or the EMF that we got for the circuit is the same as the potential difference across the battery. It's BLV.